Good afternoon, Mech 1070 team. Today we are here to present to you our last and final project. We are also known as the Hopping Hyenas, and I will start introducing our group to you now. First off, we have Maria.
Hello, Team 70. I am a freshman in industrial engineering.
Yes, she was our captain in SolidWorks, and she was mainly in charge of the design for our gripper. Next up, we have Jackson.
Good afternoon, Mech 1070 team. My name is Jackson. I'm a freshman in electrical engineering.
Yes, Jackson was also the captain of our mat lab, and he was mainly in charge of coding. And next up, we have Christopher.
Hello, Mech 1070 team. Like she said, I'm Chris. I'm a freshman mechanical engineering major.
Yes, and he was a co-captain of our mat lab coding. And then next up, we have Melih.
Hello, Mech 1070 team. I'm a freshman in mechanical engineering.
Yes, and he was our expert within Makerspace. And then finally, hi, my name is Rosa Rodriguez. I was the co-captain for SolidWorks and helped with designing.
Hello, this is my slide, the introduction to the problem, which, as we said, the problem of this main project was to, with a cardboard plane, move certain blocks into this area right here using our gripper machine right here. We had two main tasks. The first one was to stack two blocks on top of each other inside this green area right here while using the gripper, while I successfully did it. Our second main task was to line up three of the blocks in certain areas on this cardboard plane while also using the gripper and make sure it all worked and operated well. And our solution was this, to design a end effector that, when coded correctly and produced correctly, to be able to pick up and move the blocks to certain positions where we needed them and be able to effectively run the code without any disruptions.
This is our background to solution approach. So our initial prototype design A featured a stationary and moving claw. We considered using different materials for the end pieces on the claws to allow for more grip. And this is our initial prototype design B. It features two moving claws using gears. For this prototype design, we didn't really consider it in the end because of the risk of multiple moving parts. And the different materials we considered for both designs was plywood, acrylic, and cardboard. For plywood, it was easy to use and it would require machining. And acrylic, there was too many layers we would require for our design, and we were afraid that it might slip against the plastic blocks. And for cardboard, we were afraid that it would be too brittle to hold up in the end.
And next up, we have confirmation of design. In this section, I'm just gonna mention real quick and talk about how everything came to an end and what we decided on. In the end, we decided to go with plywood because it would just offer us much more support and strength than any of the other materials that we talked about previously. We also decided to go with 1032 short, stubby screws for better support and pressure against our blocks. And we also went with the first design, the stationary claw, and then one moving claw. It would just make the design really easy and effective for what we're trying to do, which in the end ended up working in our favor.
Okay, so our last slide is going to detail the two videos we had. So first, could you show trial one? So trial one was when we were moving the three blocks into a line. We were generally successful up until about 2/3 of the way through, when, as you can tell, our claw didn't go far enough and the wobble of the claw kind of bounced into the top of the block. For trial two, however, you can see the blocks went right to the middle. Our claw did exactly what we needed it to do, and they stacked wonderfully. So there were a few sources of error associated with our project, one of which was the wobble in our claw. As the CNC machine moved, the claw or the end effector would move slightly, and that ended up moving it to block and bounce into our blocks. Another source of error was that we used the machine too frequently in a given time, and it heated up and it caused a catastrophic machine failure. If we were to do it again, we'd do it over a longer period of time, and we would account for that wiggle.
Thank you so much for being a part and for listening to our presentation. I would like for all of us to be able to come back and to say goodbye to you.
Thank you, Mech.
Thank you, Mech.
Thank you, Mech 70.